each workpiece can be mounted, and the table can be moved in the longitudinal as well as transverse direction, and these spindles are housed in the housing. These housings can be moved in this direction to accommodate the workpieces of different lengths. And then the wheels are provided for moving the table. We can also, digital display is also possible depending upon the movement of the spindle. So what is the movement can be read out from the digital displays, and then you can see the digital display, and the keyboard is also available for setting the preset values, and probes can be attached to the spindles for measurement of internal dimensions. And then you can see here the ID measurement of ring gauge by two probes. That means the ring gauge to be measured is placed on the table as shown here. This is the ring gauge mounted on the table, and probes are fixed to these two spindles. By moving the probes, we can check what is the internal diameter of the ring gauge. Similarly, we can measure the outside diameter of the ring gauges, and here ID measurement of ring gauge using a single probe, so that we can see. And then the display unit also, we can see digital display unit, and OD measurement of plug gauge. So, and here you can see a digital display. So when we move the probes, what is the amount of movement is displayed on the digital display. And finally, we can take out the inspection report using the printers. Now, presently, universal measuring machines are replaced by coordinate measuring machines. Now, let us move to the discussion on coordinate measuring machine. Under this topic, we will be discussing the following points. What is the need for faster inspection, and some basics about coordinate measuring machine, like what are the different modes of operation of CMM, what are the different configurations available in CMM, and how do we how to conduct preventive maintenance of CMM, and then we will discuss about the recent advancement in CMM, that is portable CMM and virtual metrology. Now let us understand what is the need for faster inspection. Now we have discussed in length about micrometer, vernier calipers, dial indicators, protractors, etc., which are used to measure the various features of workpieces. And these devices, metallurgical devices, are used to measure only the single feature of the workpiece. For example, micrometer is used to measure length of the workpiece or thickness of the workpiece, so like that. And for measuring the different features of the workpiece, we need to have a large inventory of instruments, metrological instruments, and with the different ranges, different accuracies, etc. So the metrological instrumentation inventory will be too large. And since we have to use different kinds of instruments to measure the various features of the workpiece, the time taken for the inspection of the workpiece is too large. Now there is a growing need for a device that can do faster first piece inspection and many times 100% dimensional inspection. In view of this, a device is constructed which is known as coordinate measuring machine, which is a sort of advancement in universal measuring machine. So this coordinate measuring machine plays a vital role in the mechanization of the inspection process. We can mechanize the inspection process in the sense in the production line itself the CMM can be introduced, and as soon as the workpiece is made, it is shifted to the table of CMM and inspection can be carried out, and feedback can be given to the software for making necessary corrections in the program if there is any deviation in the workpiece. Now let us study some basics of CMM. Similar to universal measuring machine, a coordinate measuring machine is a device used for measuring the physical geometrical characteristics of an object. This machine may be manually controlled by an operator, or it may be a computer controlled machine. Data collection system is used along with the CMM, and data collection system typically includes a machine controller to control the movements of CMM, and there is a desktop computer which has a software to take the data points and to analyze the data points, and after analysis of the data points it gives the inspection report. Measurements are made by a probe attached to the third axis of the machine, which is known as z-axis of the machine. Now we can see a stylus attached to the probe head of CMM. So this stylus will move into the hole and it makes contact with the surface of the workpiece, and then again it is moved in this direction, and then again the contact is made. Now when it makes contact with the workpiece at this point, the XYZ coordinates of this particular location is given to the computer. Similarly, XYZ coordinates of this particular location is given to the computer, and the software it calculates what is the distance between these two surfaces. Similarly, the diameter of the hole can be found out by making contacts at 3 points, and using the data points of the coordinates of these 3 data points, software will calculate what is the location of the center point, and then it calculates what is the diameter of the workpiece. Like this, by using various subroutines, the features of workpiece can be assessed. Now the probes attached to the CMM may be mechanical type or optical type. By using mechanical type of probes, we can measure the various features by making contact with the workpiece surface. In case of optical probe, there is no contact between the optical probe and the workpiece, so it is a non-contact type of measurement. And probes move laterally, that is in the x and y direction, x direction and y direction, and probe also moves in vertical direction, that is z direction, and the data points are recorded. Coordinate measuring machines consist of a platform, that is a work table, on which the workpiece being measured is placed. If depending upon the requirement, maybe a fixture is used to mount the workpiece, or the workpiece can be directly placed on the work table for measurement purpose without using any fixture if it is a simple workpiece. Then they are versatile in their capability to record measurement of very complex profiles with high sensitivity and speed. Uh, Whenever we need to measure the complex profiles, we can use a scanning type of mechanical probe which will move along the surface, and then data points are recorded, and then the profile can be evaluated. Now, these CMM machines can be placed very close to the machine tool for efficient inspection and rapid feedback, for correction of processing parameter before the next part is made. That is, workpieces need not be moved to metrology lab. CMMs can be moved to the place where machining is going on. That is, CMMs can be installed in the production line itself. So as soon as the part is produced, it can be inspected. They are made more rugged to resist environmental effects in manufacturing plants, such as temperature variations, vibration, and dirt. If temperature variation is there, or if there is vibration, so automatic compensation is made using necessary software. Now let us see how the CMM looks like. I can see this is the table. It can be a granite table or a cast iron table, which has a flatness of fraction of a micrometer. And on this table, we can mount the workpiece directly. It can be placed on the work table surface itself, or if necessary, a fixture can be used to mount the workpiece. And then we have in this particular configuration, we have two columns. This is column 1 and column 2. These two columns move along the y-axis by using the ball screw and appropriate drives. You can see there is a dust cover to cover the ball screw so that dust will not accumulate on the lead screw. So at this place, the column number 1 will be moving on the granite surface. There will be air jets below this column surface so that it moves frictionlessly. Between these two columns, there is a bridge, and this bridge carries the probe head, and we can mount the different kinds of probes to this probe head, and this probe head can move vertically up and down in the z-axis by using the appropriate drive system. We can move the stylus in x, y, and z direction by operating the joystick. You can see the joystick, and you can various subroutines are available. We can select the subroutines by using this keypad. For example, measurement of diameter of a hole, or the angle between two surfaces. Like this, appropriate subroutine is selected, and then the data points are collected. We can observe a stylus stand here directly mounted on the surface of the granite table. This stylus stand holds the stylus of different uh, size